Welcome to Project Management. In this video, I will talk about project progress monitoring and performance evaluation. The project manager needs an information system to collect the data and to report progress on cost, schedule, and specifications. The data that need to be collected include the current status of the project in terms of the schedule and cost, and remaining cost to complete the project, the date that the project will be complete, and the cost or schedule overruns and the reasons for them. The data collection task also needs to identify who will collect project data, how and when data will be collected, and who will analyze the data. After data collection and analysis are done, we need to generate the report and decide who will receive the report, how the report will be transmitted, and when the report will be distributed. Project progress reports commonly include the following components: the project progress made since the last report, the current status of the project in terms of schedule, cost, and scope, the cumulative trends so far, new problems and issues identified since the last report, and the corrective actions planned for the next report period. Project control is a process of comparing actual performance against plan to identify deviations and take appropriate corrective actions. Control holds people accountable, prevents small problems from mushrooming into large problems, and keeps people focusing on project success. The control process can be divided into 4 steps. First, set a baseline plan for the project. The baseline is derived from the cost and duration information found in the work breakdown structure, and time sequence data from the project network and resource scheduling decisions. Second, measure actual progress and performance of the project. Time and cost are quantitative measures of performance. We will soon learn another concept called the earned value, which provides an estimate of performance against a time-phased budget. It's defined as the budgeted cost of the work performed. The third step is to compare the actual progress against the baseline plan and see if there is any deviation. Finally, take corrective actions if deviations from plans are significant. As I mentioned, we create the baseline using the information derived from the project network and the work breakdown structure. To measure the actual time performance of the project, we can use one of these 3 tools: a tracking Gantt chart, a project schedule control chart, and project milestones. This figure shows a baseline Gantt chart for Botanic Garden project. The project involves 6 activities. It starts with garden design, which takes 1 week. After the design is complete, the work on walkways, irrigation, and fence can all start. They will be finished within 3 weeks. After walkways are done, we may start to work on lighting, which lasts for 3 weeks. After lighting, irrigation, and fence are all done, the final activity, planting, can start. It lasts for 2 weeks. Overall, the project duration is 9 weeks. The dependencies are shown with vertical connecting arrows. The horizontal arrows represent activity slack. This figure shows the tracking Gantt chart for the project at the end of the 5th week. The baseline duration of each activity is denoted by a yellow bar. The actual duration of the activity is denoted by a green bar. We can see from this diagram that the design activity's actual duration is the same as planned. The walkway's actual duration is also the same as planned. Irrigation is planned to last for 3 weeks, but it is actually completed in 2 weeks. Building the fence is planned to last for 3 weeks, but it's actually completed in 4 weeks. For lighting, it's planned to last for 3 weeks. By today, 1 week's work has already been done. It's estimated that another week, instead of 2 weeks, will be needed to finish the remaining work for lighting. After lighting is done, planting can start earlier than planned and will last for 2 weeks. The project's duration is estimated to be reduced to 8 weeks. This is an example of the project schedule control chart. The chart is used to plot the difference between the planned schedule and the actual schedule of activities on the critical path at the report date. The horizontal axis is the reporting period in weeks, and the vertical axis is the time period in days. At the end of the first week, the project is behind schedule by 2 days. At the end of the second week, the project is behind schedule by 1 day. At the end of the third week, the project is behind schedule by 3 days. By the end of the fourth week, the project is back on schedule. And after that, the project is ahead of schedule. Overall, it shows the project was behind schedule early in the project. The plot suggests corrective actions brought the project back on track after the fourth week. Some stakeholders, such as top management or regulatory agencies, often neither need or desire a detailed project progress report. They will be satisfied with project progress toward major milestones. Milestones are significant project events that mark major accomplishments. Note that project milestones are events, not tasks. It's a time instant, not a duration. For example, there are 6 planned milestones for a house building project. The project team should receive the approved permit to build the house by April 1st. The concrete foundation should be done by May 15th. The walls and roof should be mounted by June 15th. The plumbing job should be done by July 15th. The electric wiring should be done by August 31st. The final cleaning and project inspection should be passed by September 31st. Here are some general guidelines for setting milestones. You should avoid the temptation to overuse milestones. Only important deliverables or achievements should be used as milestones. Milestones should not be placed too far apart or too close together. The start of a merge activity and the completion of a burst activity are often good options for milestones. For example, on the right side, the start of merge activity M indicates a significant amount of activities such as J, K, and L have already been completed. The completion of burst activity A indicates a significant amount of activities such as B and C are about to start. To measure the actual cost performance of the project, we can use the earned value cost schedule system. It's an integrated project management system based on the earned value concept that uses a time-phased budget baseline to compare actual and planned schedule and costs. Here is a glossary of terms in this system. EV stands for earned value. It's the budgeted cost of the work actually performed. It's equal to the percentage of work completed times its original total budget. PV stands for planned value. It's the budgeted cost of the work scheduled in the baseline plan. AC stands for actual cost. It's the actual cost of the work performed. CV stands for cost variance, which is the difference between the earned value and the actual cost. A positive cost variance indicates the earned value is greater than the actual cost, which means the cost is under budget to date. A negative cost variance suggests the earned value is less than the actual cost, which means the cost is over budget. Therefore, we would prefer to see a positive cost variance. SV stands for scheduled variance, which is the difference between the earned value and the planned value. A positive schedule variance indicates the earned value is greater than the planned value, and the project is ahead of schedule to date. A negative schedule variance suggests the earned value is less than the planned value, and the project is behind schedule. BAC stands for the total budget at completion. ETC stands for the estimated cost to complete remaining work. EAC stands for the estimated cost at completion, which is the sum of estimated cost to completion plus the actual cost. VAC stands for cost variance at completion. It indicates the expected actual overrun or underrun cost at completion. It's equal to the total budget at completion minus the estimated cost at completion. These concepts could be confusing. Let's see some examples to clear up the confusion. A small project has a total estimated budget at completion of $1,000 and the estimated duration is 4 days. At the end of the second day, the project is supposed to be 50% complete. So the planned value is $500, which is 50% of the budget at completion. After the project manager counted the number of completed work packages, he found that the project is actually 40% complete so far. So the earned value is $400, which is 40% of the budget at completion. The manager also found out that the actual cost AC incurred so far is only $300. Based on the information above, we can calculate the cost variance, which is the earned value minus the actual cost. The result is positive $100. It means we are under budget right now. We can also calculate the schedule variance, which is the earned value minus the planned value. The result is negative $100. It means the project is behind schedule. This is a cost schedule graph, which demonstrates those concepts more comprehensively. This is a complex graph. Let me show you how to read it step by step. The horizontal axis shows the number of days. The vertical axis shows the amount of money in dollars and percentage of the planned budget at completion. There are 3 different curves. The blue curve in the middle is the planned value, PV, as a baseline. The budget at completion, BAC, for the project is $100 or 100%, and the duration of the project is 5 weeks according to the baseline plan. The red curve at the bottom is earned value, EV, and the green curve at the top is actual cost, AC. At the end of week 3, which is today, the planned value, PV, represents the planned spending, which is $50. But the actual value, AC, which represents the observed actual spending, is $75. And the observed earned value, EV, with that actual spending is only $25. On the top left corner, we calculate the cost variance, CV, which is the earned value, EV, minus the actual cost, AC. It equals negative $50. That means we are over budget so far. The schedule variance, SV, is the earned value, EV, minus the planned value, PV. It equals negative $25. It means we are behind schedule. At the end of week 3, the manager updated the estimation, and the dotted green curve at the top represents estimation towards the end of the project. The estimated cost to complete the remaining work, ETC, is $50. The new estimated cost at completion, EAC, is equal to ETC plus the actual cost, AC. And the result is $125, which is 125% of the baseline budget at completion, BAC. The project time is also extended from 5 weeks to 6 weeks, a 1-week schedule overrun. So the cost variance at completion, VAC, which is equal to the budget at completion, BAC, minus estimated cost at completion, EAC, is negative $25, which marks a 25% cost overrun. Once you understand the cost schedule graph, you will be able to use it to quickly determine the project status using the earned value system. For example, in the top left corner, we have a cost schedule graph that shows the planned value curve in the middle, the actual cost curve at the top, and the earned value curve at the bottom. After calculation, we find out both the cost variance and the schedule variance are negative. So this project is over budget and behind schedule. For the cost schedule graph at the top right corner, the cost variance is negative, but the schedule variance is positive. So the project is over budget but ahead of schedule. The third graph at the bottom left corner shows that both the cost variance and the schedule variance are positive. So the project is under budget and ahead of schedule. The last graph at the bottom right corner shows that the cost variance is positive and the schedule variance is negative. So the project is under budget but behind schedule. Cost variance and schedule variance are absolute values that measure whether the project is on budget or on schedule. Some project managers prefer to use the cost performance index and the schedule performance index instead of cost variance or schedule variance. Cost performance index, or CPI, is equal to the earned value divided by the actual cost. For example, at the end of the third week, the earned value is $25 and the actual cost is $75. The cost performance index is equal to $25 divided by $75 and equal to 0.33. It means 0.33 worth of work has been completed for each $1 actually spent. Schedule performance index, or SPI, is equal to the earned value divided by the planned value. For example, at the end of the third week, the earned value is $25 and the planned value is $50. The scheduled performance index is equal to $25 divided by $50 and equal to 0.5. It means $0.5 worth of work has been completed for each $1 worth of scheduled work. We can use this table to interpret the values of these indexes. For the cost performance index, if the value is greater than 1, then the project is under budget. If it's equal to 1, then the project is exactly on budget. If the value is less than 1, then the project is over budget. For the schedule performance index, if the value is greater than 1, then the project is ahead of schedule. If it's equal to 1, then the project is on schedule. If it's less than 1, then the project is behind schedule. We can keep track of the indexes and plot them in a graph like this. Note that this hypothetical example is not linked to any of the previous examples I showed you in this video. You can clearly see that the cost performance index, CPI, was greater than or equal to 1 for the first 3 weeks, meaning the project was under budget originally. But starting from the 4th week, the index dropped below 1, meaning the project was over budget. The schedule performance index, SPI, was constantly less than 1 starting from the 2nd week, indicating the project was constantly behind schedule. Okay, in this video, we talked about how to utilize the tracking Gantt chart, the control chart, and milestones to monitor time performance of a project. We learned the significance of the earned value system, and how to calculate and interpret cost and schedule variances, as well as how to calculate and interpret performance indexes. This is Wang, and I'll see you in the next video.